So today I will talk about Dalia, the knowledge base for fair data usage and supply as knowledge graph. For those of you who are not so familiar with the status quo in chemistry, I mean, here are also some colleagues who are not from chemistry. In chemistry, we have a funny situation at the moment, or already for the last years, I would say. We are still 80% working really with analog paper and pen notebooks in the laboratory, really with manually drawn molecules, manually drawn recipes, I would say. Then a lot of the working group's data are stored on hard disks somewhere in the corner of the laboratory or in the corner of the office of the bosses, for example. On the other side, we have super cool new machines, millions of euros, I would say, and they are sometimes connected. They're connected to servers and they're connected in between and produce more data each year. I think the measurement, I saw some statistics that every 2 years, the amount of measured data is doubling in natural science, which is a large amount. But in the end, when it's around to publish, then again, we are publishing it in a PDF format. And for example, NMR spectra are then published normally as figures in supporting information. And this is not machine readable. Even if there is an assignment, in the end, it might be blurred. So you cannot see the details. So over the whole process, in the meaning of the FAIR principles for fair data, this is an unfair process because these data are not really findable in the end and they are not accessible and way beyond being interoperable or reusable. So we have to change this, and that is one of the goals of NFDI for Chem. And the vision was that we change this really old principle. I mean, here's an example which is around 100 years old. 100 years ago, one had already a paper notebook. And by the digitalization and the development of standards and the support for the community, we try to establish really the life cycle of fair data, which means that in the beginning, the experiment is planned and performed, and the data are collected, and all this is collected, for example, in an electronic lab notebook. Say Chemotion, for example, as open source, like we do. Some examples will follow later, or also others which are on the market. Then the data are processed, in best case also happening in the ELN. They are analyzed, they are preserved, they are published. And this means that they are not just published as a manuscript in some journal, but that they are also published in form of a deposit in a data repository, for example, or as a true single data publication. So there are different modes how the data can be published, such that they can be reused later by you or by others in the scientific community, and they produce new data so that the data life cycle is closed in this way. So that is the vision of NFDI for Chem, and so many working groups are struggling at the moment and working towards this goal to establish this in this year and the next years. And we found that it's important to do some more efforts in the teaching of research data managing, because when you talk about research data managing, you normally think of the PhD students and also the senior PIs and the postdocs who are performing the research. But in the beginning of every PhD thesis, the PhD students need to get into some work organization, how they organize their data. So you need teaching materials for the working group, and better it's to already start in the master thesis. And the earlier you start, the better it is, because now at the universities in the first semester, we have already the digital natives, which have everything in their cloud and on their smartphone. But when it comes into the lab work, they are again having all it on paper and pen. So this means that within the section EduTrain, we developed a concept that we thought we need teaching materials for all branches of science, so all over NFDI, for all consortia and for all disciplines, but also for all RDM levels, because there are a lot of beginners, but also advanced people, expert people, and the super experts are then the data stewards who help others to get the data organized in a fine way. And on the career level, I think we need materials really for students, really first-year students. So in some of the curricular norms, there is now, for example, from the GDCH, the recommendation to include materials for data literacy for students, really in the bachelor degree. Also the master degree for the PhD students, also for the established researchers, and also for the professors, because they, in the end, have to publish the data together with their students and to obey certain data management plans, data management rules, for example, from the DFG, from EU funders, and all the funding agencies. So there is a need on all career levels in all disciplines. And in NFDI for Chem, as in many of the other consortia, a lot of materials for the faculty are developed. For example, a lot of workshop material is developed for RDM workshops and Chemotion workshops. Within our NFDI for Chem, we are performing the Chemotion Q&A sessions. There are many best practices, videos. It is already integrated in the lab stages, and I will shortly come to every point in the next minutes. And all these materials need to be collected and organized, not only in NFDI for Chem, but also in the other consortia. And what we are doing until now, for example, in Chemotion, we are using now for almost 3 years in my working group, and also in publications. So in every publication, we deposit really the compounds. For example, here we have deposited 28 compounds in Chemotion. And normally this is quite convincing for other chemists if you see that real chemistry has been deposited in the Chemotion repository, so in a general molecule Chemotion, in a molecule repository, for example, for copper chemistry, but also for our zinc chemistry. And I mean, I'm coming from synthetic chemistry, synthetic bioinorganic and bioplastics chemistry, but we are also doing a lot of simulations, let's say density function theory, but also together with colleagues, different simulations with engineers, for example. And also there we have examples which do not fit really into Chemotion as repository, because this is rather for molecular data. But if you have computational data, then you, or for example, MALDI-TOF data, mass spectra from polymers, then you can put it also in radar for Chem. So there are, for different parts of data, pieces of data, there are suited repositories which are already working now, already for more than 1 year. And so it's important to show to the community as best practices what is already possible now and what is really possible for free, because sometimes some publishers offer, I would say, offers that you say, give us your data, we prepare the data, and then we put them in some repository, but it's not for free. And I think it's important that all these data which shall be published and deposited should be possible to deposit them for free, because we don't have funding for putting data somewhere. Going a little bit further, how we can integrate this into teaching. And the problem is always the discussion about integration into curricular teaching. As I saw here in the audience, there are many people from universities, and you know that universities are slow in their decisions and also slow in changing things. Which means, for example, in Aachen, we have freshly accredited, how is it in English? The accreditierung has just run through. It was successful. It's fine. So we don't want to start all over again and say, now the first semester we did net data literacy. So we need some way to change teaching without changing the curriculum in an accreditierungs process. So, for example, what I'm doing now for several years is that I'm having a master's lecture on sustainable coordination polymerization catalysis, which means it's a normal master lecture, Wahlpflicht. So those who are sitting there are sitting willingly there. It's 2 hours per week, 80 to 100 students, in the end with a written exam. And normally I teach with case studies and also normal hours with lecture style. But meanwhile, I'm always searching for case studies with really good examples of research data management and really bad examples. And I always try to find really actual examples of bad examples. And I have the impression that the students are really learning good with bad examples to show how one should not do it. And by presenting the research data management in a practical way, it's better. The material is not so dry, I would say. And we are also integrating videos on the basics of RDM. So what is fair data? What is the data management plan? For example, from our library, but also those from NFDI for Chem, which we have developed. And this is running quite well, because then the students take up the most important concepts and go with these concepts on toward, for example, their master thesis. But what we also learned is that we can implement the Chemotion as electronic lab notebook even earlier, which means, for example, in my working group, Fabian Fink is a super user. Already this week, he was active on, I think, 2 workshops, Chemotion workshops, to present Chemotion to a large audience in Regensburg and also in Rostock, because we have implemented the Chemotion ELN all over my working group with 30 participants now. And this is going to get practical for the whole working group, because it's a concept which is integrating all the data which we have. And we just published last year this best practice paper to showcase how you can connect chemistry over a working group by using an electronic notebook, because you have a working group integrated database by this. Some example, yourselves, for example, we are doing a lot of guanidine chemistry, and these ligands, they have, I would say, sister ligands. So, for example, here's a tetramethylguanidine anthracyl acid methyl ester. It's come from the German name. So this is this compound, and there are, of course, derivatives, for example, with a dimethylamine group here. And with this, we can then produce iron compounds, zinc compounds, and with them, we do a lot of polymerization chemistry. And within the Chemotion in our working group, then everyone can share the data. So multiple students are working. For example, a bachelor student is working together with a PhD student, or a postdoc is working again with the same ligand, but another iron salt, or they use a simple iron salt, and then they do polymerization. And by having all the data together in the digital way, you have a larger overview of what's really going on in the working group. We have developed guidelines for sharing the data, who can share within the group, but how can it be shared to the others? For example, when it's then published, finally, it is shared to the outside via the, in fact, by pushing the button to go from the Chemotion ELN to the Chemotion repository. And we also have developed a group policy, how we can work on to have a best practice. And for example, we developed a pictogram permission level, who can share the data with whom, because in the beginning we saw, if, for example, the bachelor student gives the data to the master student or to the PhD student, then just eventually it can happen that data get lost if some buttons are pushed too early, or in some case. So because you can share the data, you can synchronize the data. So you need really a good organization who can share the data of whom, and who has access to general data, I would say. General chemicals in the general chemical database, for example, are shared over the whole group, and who is checking the data of whom. And here you need really a good organization, which is working quite nicely now. Go a little bit on. But what we also need is, I mean, every bachelor student, every internship student or master student who comes into the group needs also some help. And therefore, there is a comprehensive online manual. For example, it's called the Chemotion Saurus, but also introductory videos and in-depth videos for those who are a little bit more advanced. And in the meantime, Fabian and the whole team developed a large series of tutorial videos, for example, together with Salim and Henrika and other members of my group. That at the moment in German, but they just have translated it all in English, and this will be launched soon, which means really the first step of explanatory videos, how to get started with Chemotion, how to make a collection, how to draw the molecules, how to import data. This is really a step-to-step approach, which has been published on YouTube and Zenodo. And this is also quite practical, not only for the working group, but also for the people going into the lab stages, for example, in the bachelor degree, but also a little bit earlier. And that is now showing on the next slide. So in every winter term, we are performing a lab stage in advanced inorganic chemistry in the 5th semester. So these are normally 130 students, and they normally perform 3 experiments. They synthesize ferrocene, which is a standard, I would say a standard organometallic compound, which is produced in many universities in Germany, because it's really a compound in which synthesis you learn a lot of the Schlenk technique, for example, how to work cleanly and accurately, and how to document this. And also for this lab course, we thought it would be good to make the people familiar with Chemotion as ELN. And also here we used to integrate, we integrated videos on the basics of research data management, but also what are the FAIR principles, metadata, what is INSHI and SMILES. And then they could really use all what they have learned on the synthesis of ferrocene and make the whole process in the Chemotion ELN, which is in the end also substituting the old standard paper protocol. So for example, in the synthesis of ferrocene, you have multiple steps. First, you have to prepare from iron and iron 3 chloride, the iron 2 chloride as a metal compound. Then, for example, you have to prepare you have to crack, for example, the dimeric cyclopentadiene. This is then, for example, deprotonated to obtain the cyclopentadienate. And in the end, this is then combined. So all the steps are then documented in the Chemotion. which it looks like this, for example, then you can really see how many milliliter, how many gram, how many millimole. This is then also filled automatically by the ELN, which is quite practical. And in the end, they get then, for example, the NMR spectrum, which is not so exciting for ferrocene, but you can also integrate it into the Chemotion ELN. And yeah, Fabian was also quite active together with Alexander Hoffmann, who is leading this whole lab stage. We performed an online questionnaire in the last years, and this year it will also be done again. And from all these numbers of students, around 34% were participating to this survey. And what I don't want to go with you through the whole service, don't worry. But what's interesting is, if you look at these orange bars, they are from the winter term 2020-21. The blue from 21-22, so last year. And what you see is, if you have the question, how difficult was it to use the ELN? Then 1 is difficult and 10 is easy. Just as trend, you see that the blue bars are shifting a little bit more to the right-hand side. So it seems to be to get easier for the upcoming students. So it will be really interesting to see the new trend from the actual running lit course at the moment. And what's also interesting, we also question them, do you understand the benefits of storing data digitally? And here also the blue bar shows that in the next term, the understanding why research data management is important is better understood and better accepted. And also the reservation. So for example, here, a lot of them said they prefer the handwritten laptop notebook. And some of now really saying that they enjoy using it. So also this is shifting a little bit, might be a case of generation, that the upcoming generations of chemists are already more digital than the older ones. So we have to look over the years, but it also underlines the importance of nice teaching materials here. Also, the question was if they might use it next in the bachelor thesis or the master thesis, or if they also think that that the documentation might go faster or slower on the long run. And here is the limit of, they think it's going slower, and here they think it will be faster. And in the first year, a lot of the people thought it might slow down the documentation. And I have now the impression that more of the half things, it's getting faster. So that is the goal in the end. Our research data management should not make things slower. It should not slow down science, but it should enable science to be more efficient and also faster in the end, so that we have more time to think about the results than about the saving of the results. So NFDI for Chem is giving a lot of material, and of course there's also a motivation for all the chemists in Germany, because the DFG is really pushing in this case that we have data management plans in our Normalverfahren proposals, for example, and that we save the data not just on a disk in the shelf, sondern that the data are really lying in repository because they were produced with taxpayers' money in the end. So this is the motivation. So that's a little bit like a carrot and a stick. So we have to push the people a little bit, and the people are also pulling the interest from the interest and are seeking for new materials. And within NFDI for Chem, we have a huge team. Meanwhile, also from the Mainz people, it's driven quite intensively. That there's a 2-day workshop introducing the basics of RDM from a chemical perspective, of course. Meanwhile, we have also developed a 1-day workshop as a compact workshop, because some people think that the 2-day workshop, I think it's really super, but for some bosses it might be too long, so that they don't send the people to the 2-day workshop. So now we have a super compact 1-day workshop, which is also reaching out to the people. And this material is inspired by others. I mean, we are standing on the shoulders of giants already there, because there is already wonderful material from FD Mentor, for example, from the University of Mainz, also from Aachen University, from Jena, and from the TU9. But really often this material is quite generic. So we try to assemble it and to fit and to adapt it to the chemist's need. Yeah, and what is the content of these workshops? Of course, as I said, the basics of RDM, but also what is a controlled vocabulary, naming conventions, an overview of electronic lab notebooks, data loss and data preservation, how the data can be published in the end, and to find the right repository. I mean, someone from organic or inorganic synthetic chemistry has a different repository than, for example, a physical chemist or a theoretical chemist who has different data, different amounts of data. And so for each discipline and for each scientific question, there might be a better choice to find the right repository. Also, legal aspects are important, and in the end, thinking of EU proposals and DFG proposals to how to create the data management plans, which is also quite important. Going a little bit further, more than 1 year ago, the NFDI section EduTrain was founded. Peter Pelz from TU Darmstadt is now the speaker, and I'm the co-speaker. And we collected together with the community a larger concept, which has been published in Zenodo. But in fact, the sections do not have money to perform their work. So there is a lot of willing people who want to do something, but they all have their normal daily work in the NFDI and their consortia. And so it was important to get funding to have the technology as basis, as platform underlying the whole section. And this is now the project Dalia, and only has to have the logo in German. So we formulated as a question, like you ask Siri, where is the next bus stop? You can ask Dalia, how do we develop a platform for data literacy, or how do we build, for example, findable teaching materials? And here's the list of the partners. So or the Darmstadt partners are also in some part here. But for Aachen, we have 2 partners. So we have me and my group, and also the IT center headed by Matthias Müller from our IT center, where we are closely collaborating. But it's not just driven by the IT people, the engineers, the chemists. We also were successful to get Professor Schade from the Academia of Science and Literature in Mainz as Digital Academy as partners, because I think it's important to also have people on board from different branches. So, for example, the Ulrich Sachs from medicine or medical informatics, but also the people from the library, for example, the group of Professor Stecker and also Dr. Gischmörk from the TEB, to get a broad overview over the materials and over the different perspectives on teaching RDM and teaching materials. Yeah, and going a little bit more into Dalia, the full title of Dalia is in fact that it's a knowledge graph of the Data Literacy Alliance for fair data usage and the provision based on a semantic web technology, which means we have to think about the fair data, the data value in itself. The data also have costs, and they have regulations depending on which branch of science you are working in. It might be that your data are regulated, how you publish them and where you publish them. For example, if it's medical data, you have to think about how to analyze, for example, and also how the data are governed in the end. And there are many needs going right into the heart of the data. For example, how you can use them in a public way, or which needs to be private, and the ethics of the data, so how you can use the data and reuse the data. And we are setting out now to develop a user-centered knowledge base. That means that we really are keen to identify and meet the needs of the users, because there are so many people out there who need help with research data management and need training materials for this. And of course, we need to provide a quality assurance and the creation of the content, of course, all together with EduTrain. So we will develop quality standards and concepts for fair teaching and training materials. So the materials on fair data or the research data management shall themselves be fair, so that they have metadata, for example. And also concepts of natural language processing shall be implemented, and semantic networking and reasoning, together with a networking engine, a recommendation engine. This is important because sometimes, so we learned in our workshops that sometimes people don't really know what they are looking for. So for example, 10 years ago, if you would have asked me, what do you want about the repository? I would have said, huh? Because if you don't know what a repository can do, you would not search for information about a repository. So sometimes you have to learn to get a glimpse about a concept to look for more, which means here, for example, when the Dalia platform is running and you have your login and you look, for example, for DMP training material and something on fair data and fair principles, then perhaps the recommendation engine says, aha, are you also interested how to store the data here or how to process the data publicly in a repository? And then you can click on, and just like Amazon recommends a book to you, also Dalia would then recommend teaching materials on the right level to you to develop a little bit where you can go in your learning process, but also in your teaching process. If you are, for example, designing a seminar or a full lecture for master students, or for professors to convince them to use now more fair data in their faculty or in the full department. And of course, they need to be overlapped to other platforms, and also the possibility to have a single point of entry in the end. So going a little bit more into the detail, we have 5 Arbeitsbereiche, so work packages. The first one is quality assurance and sustainability. And here the goal is to develop really a quality for the standards of teaching and learning materials and the involvement of providers, because there are already large amounts of teaching and learning materials all over Germany, or also all over Europe, or also free, also open educational resources. But sometimes the quality is a little bit mixed, I would say. So you look for something for chemistry, use the keyword chemistry. In the end, you find some data or some teaching materials about RDM and astronomy. And I think, ooh, that's somehow a little bit strangely tagged, for example. And sometimes the data are not on a really good standard to really use them for teaching, which means that we need a good quality standard and a good curation. Also, we need a high level of communication in the community to get the data or get the teaching materials, but also that the teaching materials get again used. So the involvement of future users. In work package 3, we all work together on the information model. So how can teaching materials be tagged in a meaningful way and put then in the platform, so that the platform digests all the material and again offers them to the user. And here for quite connected is then the work package 4 with the infrastructure, that we need a sustainable platform and a stable platform. It might be then that in the next years, every day, thousands of people want to be on the platform and use the material. So it has to be quite robust. And we need also the integration of a search and recommendation service, as I already mentioned. We in Aachen are quite involved in not all sub-work packages, but for example, in work package 1 and 2 and also 3, because we have to anchor the provider community in the NFDI section, because in the NFDI section, EduTrain, a lot of people working with teaching and training in the RDM region are already quite active. And so they have to be involved to give their material into the platform. Then we can work on the curation of all this data and also work on building a user community, which also gives back again on the teaching material. Might be that we, for example, are taking material and say, this is suited for master students, and another person says, oh, I also used it for fourth year student or fourth semester students, but you can add this and this material. So that might be a learning process also in the community, how we as a community use our teaching materials and develop new teaching materials. I'm not just thinking about slides, PowerPoint slides, but also exercises, self-evaluation tests, small videos with in between questions as for explanations, for example. There are so many possibilities of teaching materials, which then can be stored and tagged and also distributed by this. And also we have then to work on the inventory of the platforms, what's already there, and also requirement analysis based on user stories. I would like to present also the technology platform, which we like to use. Here is the EDUA platform. It's not my invention. So Gabor has worked really intensively on this at the TIB in Hanover. And the EDUA is an open community-based AI-driven learning platform, which already has a recommendation engine. It's already running, but not for teaching materials. It's at the moment, it's rather a tech platform, as I would say. And we will, we will adapt it a little bit for Dalia. And what I really like is the objective of the EDUA, because you can start to have personalized learning and curriculum recommendations by defining your own learning goals and also by using this recommendation engine, so that you have really an interesting open educational resource which is adaptable to the needs. So someone who is then, for example, searching for material for the master student or the PhD students, or for example for material in the connection. For example, I'm collaborating a lot with engineers and physicists. Sometimes you need different teaching materials if you are talking to an audience between chemistry and physics, really at the frontier of science. And I mean, exactly as a frontier, the new science is happening and these data need to be stored. And so exactly there, you need support for all these materials. And so we think that will work with the EDUA platform. How would this go in the end? So for example, if then when the platform is running, we have the learners, they set, for example, their goal, what should be learned, what would be the skills and the competencies, what is successful in the end, and then we have the content in the platform, and this will be helping to match the goal skills, and also the skill topic will be matched, so that the platform gives the right material and helps in this. So in the end, we need a high quality of the metadata and the technical quality to really come to this goal, and to have sustainable educational resources which are up to date and are also used in an active way. And in the end, when all is finally running, then we have also the possibility of learning analytics, so we can see this set of videos has been downloaded 300 times and 250 people found it helpful for teaching chemists or physicists or in the life science, or to teach Americanists or other branches in science, for example. So this is how it should look like then in the next years. And now I think this is like a call to the community. We need to collect the material from the whole of the NFDI, but also from the Länderinitiativen, so from the RDM initiatives of the federal states, and together with the NFDI Datenkompetenzprojekt, the data literacy project. I'm not sure if they have an English name until now. There will be a community workshop on the 23rd of February, where the data competency offers all over Germany shall be collected and mapped, I would say. And I just want to advertise this here, because it's quite important that many of us will contribute. I think it's still open to be for registration. Okay, finally, I would like to thank all the funders, for example, the DFG for the NFDI for camp funding, and also Dalia with the BMF, and also you for your nice attention. Thank you.